have Youyou here today. For those of you, which is unlikely to not happen to know her, she is one of the most established researchers in computational social science. She spent a great deal of work on inferring psychological phenomena from digital data, text data, online social media data. One of her papers has been in 2015 in the top 20 most cited, I think, but it was more about attention. So most aware papers worldwide in the public mind. That's really summarized based on the CV of yours. And she's also happens to be the only person I know who has the highest number of, who has only high impact publications. So I don't know anybody else who has more PNAS publications in the total number of publications. That not being, of course, the only metric of scientific excellence. We'll hear more about that today. And yeah, she's now at UCL in London. She has been doing her PhD in Cambridge, but has been also working at Kellogg's and Northwestern University as postdoc, and has been working at Facebook in the people analytics team. So many insights from industry and academia. And today we'll hear more about her new research stream, which is a very current topic, not only in our field of studies. Psychology has been pretty heated topic for a while now, but it's a big problem we're having in research and science in general, that findings don't replicate. And Youyou will tell us about a new method, how we could potentially estimate replicability of the research that we are doing, that we are reviewing, and they were reading on a daily basis in journals and conferences. So I'm very happy to hand over to you. We're very happy to have you, and we're very excited about your talk.
Thank you. I'm really delighted to be here, and thanks for the really nice introduction. Not sure I'm as amazing as described, but yeah, so today I will be talking about replications. I assume most of you know what a replication is. You repeat an experiment or a study, and you compare the original results with the replicated results to see if they align. And I want to give credit to my collaborators, Dr. Yang and Brian Woozy. They're my collaborators at Kellogg. Yeah, so I want to start by reminding you of why we do replications, and there are two main purposes. And the first one is to evaluate for a field the overall replicability of research. Say for you, for example, you want to know how replicable in general psychology is, or marketing is, or whichever discipline. And that is different from if you want to assess whether a specific finding is replicable. Like you can focus on just one effect in social psychology, the ego depletion effect, just targeting that effect, whether it's robust. And these two purposes, they differ in the way replications are done. So on the right, imagine this grid represents the entire literature base for a discipline. And if we want to evaluate the overall replicability of research in that discipline, and then you only need to take a random sample of studies and replicate that small subset. And an outcome would be an estimate of their success rate. And example of that, of replication projects done for that purpose is the famous RPP studies published in Science, Reproducibility Project Psychology. They replicated 100 randomly selected studies in social and cognitive psychology and found that 60% of them, or about that rate, failed to replicate. And using that figure, you can infer the status of the entire literature base. So we would estimate on average, psychology studies, or at least social and cognitive psychology studies would on average replicate 60%, 40%. And the second purpose actually follows the outcome of the first purpose. If we know that the majority of psychology study wouldn't replicate, then we actually need to find out, distinguish between the studies that are replicable versus those that are not, looking at textbooks, whether those studies that we teach our undergraduate students, are they really robust or not? So that's why we do replication for the second purpose. And in this case, you would choose a specific finding, and then you would replicate that finding, and the outcomes is just yes or no, whether we can replicate that or not. Although it's more complicated than that. It's not a black and white picture, but every single replication, it does have an outcome of success or failure, depending, and there are many criteria that you can use to decide whether a replication is successful, like whether the p-value was smaller than 0.05 and same as the original, or whether the replication team, they subjectively assess that, oh, that was a successful replication. But in any case, usually a specific findings replication has an outcome of yes or no. And there are many examples of that. There are journals like Social Psychology, they call for special issues to replicate a lot of important findings in social psychology. There's also an article type, it's becoming more and more popular now across field, across journals, called register replication reports, where you can propose to replicate a classic finding in your field, and your paper is actually accepted before you actually do the replication. They evaluate just based on the proposal and to maximize the robustness of the effect. And there's also this organization called CREP. They every year they curate like a list of studies that they think are high impact, classic, and they encourage undergraduate students around the world to replicate those studies for their dissertation. So on a scale, they can create like a database of replicated findings. So those are examples of replications done for the second purpose. And when we do replications for the second purpose, an inevitable question is deciding which findings. Yeah.
Yeah, just have a quick question about the replication within a discipline.
Yeah.
So how do you deal with disciplines where there's a dominant theme, where you have hundreds of studies, for example, on ego depletion, maybe in psychology?
Yeah.
Is this weighting the number of studies that are in a similar? If you do a random draw, and
Yeah.
just by definition you would have, because there's just more studies available,
Yeah.
more papers available on a similar effect. Are they exclusive, or could it be that, or it doesn't matter and you just sample randomly? And
theoretically, yeah, you're right that we should weigh for, but it's also true that if there are more studies on ego depletion, then we actually care more about that. So a random draw would make sense without weighing even. But in reality, what I said, when people do replication for the first purposes, those things don't happen a lot. Like so far, maybe there are 5 projects that have done for that purpose. And each one of them maybe 50 to 100 studies. So they manually go through it, and then it's not entirely random. So so it's actually unlikely that they will do ego depletion twice and consider that as part of the overall portfolio. Yeah. Okay, so yeah, back to doing replication for the second purpose. We need to decide which findings to replicate because we have a huge literature base, and we want to, there's limited resources and also because replications are very expensive and take time. To give you an idea, and a good, like appropriate replication on average takes 300 days to complete. So it's impossible to replicate even a small sample of that huge, among that huge literature base. So we need to prioritize which things that we want to replicate first. So currently, replications are, which studies to replicate is decided by researchers' idiosyncratic preferences. Psychology, for example, likes to replicate classic high-impact studies, which is justified. But we would hope that this approach is more systematic and guided. And actually, there's a framework that's being proposed to decide if we want to decide what to replicate. And this framework proposed says that it should be a function of how valuable the study is, the outcome is, plus how uncertain we currently are about the outcome. And the value of knowing the outcome can be measured by using metrics like citation number or our metric attention score. So if a paper is highly cited, it means that a lot of the work are building upon it. So we do care about knowing the outcome of that particular finding. And also if like the public cares a lot about that finding or at least aware of it, then we also want to find out whether this effect is robust. And the good thing about citation number and our metric score capturing like media attention is that it's available for every paper. So, and it's quantitative, so we can use that to prioritize what studies to replicate first. And ideally, we would want something similar to decide the uncertainty of the outcome, and a quantitative measure available for a large number of papers. We currently don't have that yet, but we can create one. So in the next couple of slides, I will introduce two existing methods that's trying to decide how replicable the uncertainty, basically the uncertainty of the outcome, giving it the numbers. How likely do we think this study will replicate? So the first method is using prediction markets. So experts like graduate students or professors, they are invited to put their money into guessing or deciding whether a study will replicate. And as people buy and sell about whether a study will replicate, the market price will fluctuate. And eventually, after 2 weeks, the price will settle to like a number, and that number is like the market's overall confidence in whether a study will replicate. It's pretty accurate. On average, more than 80% of the guesses were correct eventually. So people do have intuitions. And not only experts, even lay people have intuitions about whether a study will replicate or not. So that is helpful. However, the downside of using prediction market is that it's not cheap and fast enough to scale to like an entire literature base. It takes maybe 2 weeks to organize like a dozen of prediction markets, and you need to pay the participants to participate and bet on studies. And alternatively, we can look at characteristics of the original study and use that as an indicator for how replicable a study is. We can look at the original p-value, the original effect size, how surprising the original result was. And this is like a low cost, no maintenance method, because all it takes is to extract these metrics from the original study and use that to predict whether a study will replicate. However, this method is not very accurate. As you can see, none of the associations between these variables or characteristics exceed a correlation of 0.3. And my team, we call these metrics reviewer metrics because these things are like are likely to be things reviewer considered when they evaluate the paper. Is there a question or? Oh.
Actually, just out of curiosity, how did you operationalize surprisingness?
Oh, that was ratings. That was manual ratings. Like you would ask research assistant how to read a paper and then say how, on a scale of 1 to 10, how surprising that is to be.
Same as counterintuitiveness?
I think it would be the same. Yeah. Yeah. But I didn't do this. This is from like a previous paper. So yeah, these are the two existing methods for predicting whether a study will replicate or quantitatively assess it. They both have limitations that make them hard to scale to an entire literature base. And so in response, our team proposed like a new approach, trying to predict replicability from the text in the manuscript. And our hypothesis is that there's information about the paper's replicability embedded in the writing, like how the author described his or her findings would reflect how much confidence he or she has in the findings and maybe the replicability of the paper. And we hope to build a machine model, like combined with text analysis, that could take in a manuscript and then output a replicability score. So there are two main advantages of this, this method. First of all, it's automated and therefore fast and scalable. The whole process runs in machine time. You feed in a manuscript and then outputs a replicability score. And the second advantage is that it's standardized. It can be any research finding we care about has a manuscript, so it can be used on any finding we care about. So unlike reviewer metric, like original p-value, like if one paper, one field uses p-value, and another one uses accuracy. So it's hard to standardize across different papers and make a predictions for all different kinds of papers. And here is the overview of the methodology. And in order to train a model to make predictions about replication outcome, we need to collect the training sample of studies that have already been replicated. And we would convert text into vectors and then build a machine learning model to predict replication outcome, yes or no. So it's a classification problem. And after that, we can feed in new manuscripts, and then the model would generate a predicted outcome, predicted replicability scores from 0 to 1. And that can be fed into like the decision framework of how uncertain we currently are about the outcome. But I just want to say upfront that this is not everything. Like even if we generate a score, it's meant to be used like as a preliminary step of deciding how likely a study will replicate. We can later use prediction markets to further refine that and eventually replicate that and decide how confident we are. So I'm not saying that if you get a score of 0.2, then you're doomed, like you shouldn't be here. So this is like a very first step of assessing a paper's replicability, nothing definitive. So next, I'm going to go over how the machine learning model is built. It's nothing fancy. We'll just start with quantifying, like converting words into vectors. And that is based on a very established model, word2vect. And the idea is by looking at the context in which words occurs. It's like first constructing a dictionary to define every word quantitatively, and then we can infer the content of the paper from the definition of words. So in order to teach the machine model to understand the meaning of English words, we collected 2 million abstracts from social science papers so that the machine knows the meaning of those words in the context of social science abstracts. And altogether, we broke it down into 9 million sentences. And then for each word in each sentence, we would extract the words that appear before that target word and 5 words that appear after that target word. So pairs of words we're extracting. For example, there's this sentence, there are many questions that our analysis does not address. Then for the first target word there, you would extract there and are, there and many, there and question, there and that, and there and are. So those are pairs of words that were neighbors. They appear in the same context. And then you will move on to the next target word and do the same thing. And after doing that for all of the words in all of the sentences, we can come up with like a giant matrix that look at how many times each word has co-occurred with another word in the same context. And this is like a giant co-occurrence matrix, and that can be condensed using the word2vect model. And eventually, each word would then be represented efficiently using a 200-dimensioned word vector. So that's like a quantitative definition of each word. And that definition, conceptually, it's like defining each word in relation to other words. And here's an example to visualize the first 3 dimensions of different words. These are hypothetical, just to illustrate what it means. You can imagine how words like dog and cat, they tend to co-occur, they tend to appear in the same sentences with words like sleep and play and eat and feed, and both dog and cat appear with these neighbor words. And therefore, in that definition, dog and cat is considered semantically related. And therefore, in that vector space, they will cluster closer together and then further away from other words like analysis, experiment, and report that has nothing to do with it, because you wouldn't expect dog or cat to appear with same words that appear together with analysis, experiment, and report. So that's basically how each individual word is being given a meaning quantitatively. And it's sort of like doing factor analysis, but although the underlying technique is different, but like each word is represented by a series of factors that define it. Yeah.
Yeah. Two big questions. So one about the training data and one about, let's say, transferability to other disciplines. So with the training data, what was the reason to go only for the abstracts as opposed to the entire paper? Was it just about
it was just a matter of convenience because all the abstracts are available in the Microsoft database. Yeah, that's the only reason. We could have gone for the entire, but we the assumption behind is that in order to define each word, like abstract would be enough. Yeah, but of course, if we want to do the same thing for like a medical literature, or then yeah, you wouldn't use social science abstract. You would use medical papers abstracts. Yeah.
Yeah, that's perfectly leading to my more on transferability between disciplines.
Yeah.
So was the idea to go for social science because we were assuming that there's more variability in terms of replication?
But at this step, it doesn't matter. It's just for defining the words. It's just for the model to understand what each word means. So it doesn't matter the replicability of different fields in social science. It will matter in the next step. But here, it's just for the model to understand the constructing the meanings of words. So it wouldn't matter. Yeah.
No, not in the model, that's clear. But within the discipline of social science, there's probably more or greater share of papers that do not replicate.
Yeah.
So you did you want to have a discipline where you have a greater share of non-replicability? Because you I don't know, I'm not sure how this is in medicine, but I vaguely know that in medicine this is also an issue. Maybe abstracts are written differently. So maybe the features that you pick up.
I see. Yeah.
There are different features because just people in medicine write differently in terms of language and style based on the kind of features that you might pick up from the abstract.
It wouldn't be helpful because if people in medicine they write in different way, and then it wouldn't be seen in social science papers that we actually want to apply our models to. So it makes more sense that the training data for this word-to-vec model is similar to the our application, our purpose of applying it to psychology papers. Yeah, I think. Yeah, that makes more sense to have training data for papers that are similar to your application. Yeah. Okay. Yeah, so now we have definitions for each word, and the next step is just to get the word frequencies for each word in each papers. And then if you multiply the frequencies of words by the word vectors, then you can get the vectors for each paper. So from step 1 to step 3, we went from quantifying words, converting words into vectors, into converting papers into vectors. And in step 3, now the machine has like a quantitative definition of each paper, of the content in each papers. And finally, we can build a machine learning model predicting the yes or no outcome of replications that we know from those manual replication studies using algorithms. And we use very simple combinations of algorithms, just random forest and logistic regressions. And here is actually the actual training data for our machine learning model. There are 388 studies in psychology that has ever been replicated. So you can see from this small sample that replication doesn't happen very fast because of incentive, because of a cost. And when we were conducting this experiment, this is like almost the whole universe of replications that ever happened in psychology, 388 studies. And it's a small sample for a machine learning task, for like such a complicated machine learning task. So it is indeed a limitation. And but we can always, replication is happening more and more often, and more studies are being replicated. So the studies could be updated to build a more robust model. And here are the results for the predictions. So on the y-axis, you have our predicted replicability score for each paper. And then on the x-axis is the ranking from low to high. And each dot, like little dot, is a paper. And the red dots are papers that in reality failed replications. And the green ones are those that were successful. So you can see that on average, the red dots with lower scores tend to fail more often than those at the top. And together, the machine was correct about 74% of these studies, and that is honestly not a good number for a machine learning task. But what we want to know is that can they provide some information? Is it at least good or better than some of their existing methods? So even this small improvement is worth implementing. Yeah.
Just a quick question: how did you get the ground truth?
The
target variable, like replicability, yes, no?
Those studies were manually replicated by people. So they actually went to replicate it, and then they decided whether it's successfully replicated or not.
There is the existence of a study,
yeah,
where they said we replicated.
Yeah,
So
yeah,
that
yeah.
is like different.
Yeah.
What's the base rate replicability?
It really differs between fields. So in social psych, it's 40%. In cognitive psych, it's 60% or 70%, I believe. And higher in personality psych, like 70%. Oh, cognitive psych is 50%. I actually have a slide of that. But yeah, it really differs. But on average, psychology, I would say 40 to 50%. Yeah.
But I think that's also important. You're better than the base rate.
Yeah.
Based on
Yeah.
what you
Yeah.
expect from a random flow.
Yeah. And yeah, but not only comparing it with base rate, we can compare it with reviewer metrics, for example. So we built the same model, but instead of using text, we use these original statistics, like the original p-value, the original effect size, sample size, the base rate. We take that into account as well, whether it's a cognitive psychology paper or social psychology paper, and also like the power of the study. And together, this reviewer metrics model will correct about 66% of the studies. So this is already better than the reviewer metrics model. And we further compared our study with prediction markets, and there were about 100 studies out of these 388 studies that also they did prediction markets for those studies. And the accuracy was 0.83, so it is higher. Like human intuition, it is better than the machine model. However, as I said, the downside is that to be able to complete just for 100 prediction markets, it took them like two years to just administer that. So our text model is less accurate, but faster and cheaper. So it's more suitable to be used as a first preliminary screening. And then maybe later, out of a smaller sample, you can use prediction markets on those samples. Yeah.
Prediction markets were based on the full papers or only the abstracts?
I think not even the abstracts. So I think they first manually summarize the finding and just using 1 or 2 sentences. And then like the experts came into the market and read those summaries and then bet on it. So not even abstract. Yeah, so I want to take the time to answer a few potential questions you might have about the mechanism of the model. I'm sure you have a lot of confusions and questions in mind, so I want to get that out first. So one common concern that I had was that people were worried that the model was just predicting the identity of the author and use that as a proxy to predict replicability rather than predicting the replicability itself. And if that is the case, obviously it can be biased against certain groups of people. But to be clear, in order for the model to use that as a proxy, replicability needs to first differ between people with different characteristics. For example, men and women having different replicability base rates. And we know that's not true, actually. We look at replication rate for author genders, author race, and how prestigious their school is, their institution is, and those are not related to replication outcome, actually. So if that is true, then there's no way that the machine can use those information as a proxy to predict replicability. And the second concern was the model was just predicting the discipline of replicability and use that as a proxy. That is possible because, as I said, social psychology and cognitive psychology, they have different base rates, and cognitive psychology replicates more often than social psychology. So if from the text, I can know that this is a social psychology paper and I just predict it to be more replicable, then that's not helpful, right? Why use a machine model? We can just know it from the categories of that paper. So to test that hypothesis, we actually trained a model on social psychology, only on social psychology paper, so that the model wouldn't learn the subdisciplinary differences. And then we used that model to predict for cognitive psychology paper and vice versa. And we actually observed no significant, no differences actually in performance. The figures were very similar if we do it either way. So that way we know that even if there are different base rates, the model is not really using that information to decide whether a paper is replicable or not. Yeah.
Quick question, do you do it only for those two or for
just for those two, because these are the in the training data, these are the main fields that were available. We didn't have that much training data for the other ones. I'm going to talk a little bit about, that's definitely a limitation, that our training sample is focused on social psych, cognitive psych, and personality psych, and there's like a few from organizational psychology, but none from developmental psychology. Yeah. So, and the third concern is that the model was identifying individual word choices, like people who, for example, use the word remarkable more often, their papers are more likely to fail. And that's like that's a dangerous hypothesis, because if the model is actually doing that and we can identify that, then of course you can write, you can throw in words that make your paper look more replicable. But that does not seem to be the case, because we did train like a model just based on frequencies of words, a simple bag of words model, but it did not perform very well. And also, we used a technique called LIME. It can actually identify whether whether a model is making those decisions based on individual words. And we found that the model decides different papers to be similarly replicable, but based on different sets of words. So there's no common set of words that's driving the model's decision. And finally, if it's not individual word choices, then it must be combinations of word choices, but that's like the building block of the analysis. So we did find that papers that failed replications are more likely to use uncommon combinations of words. But again, there's no like specific set of words that they use. That's like the only test that we found where we were successful in identifying some kind of pattern from this black box. Yeah, so those are the questions that you might have about the mechanism of the model. So let me know if you have other questions, and at the end, I can try to answer more about that. Okay, so I have presented how this method works, and now the purpose is to apply them to actual papers and then make predictions about replication outcome for a large number of papers. So we chose 6 top journals in psychology, 1 for each discipline, as well as 1 journal, psychological science, where all different areas of psychology publishes in there. So together, there are about 14,000 papers. So from the year 2000 to 2019. So if you ever publish in this journal between that time, you are in my database. I'm in my own database as well. I made the predictions about my own papers, whether that's replicable or not. Yeah, so here are the results. On the x-axis is the predicted replicability score using our model. So we hope to use that as an uncertainty metric of the outcome. And the y-axis is just the frequency. So that's a histogram for all the papers, for 14,000 papers. And you can think of this as a replicability ranking. So presumably papers on the left with lower scores are less likely to replicate than those on the right. And I further broke down this mountain into different disciplines. So, and we found that developmental psychology, which deals with children, infants, and older elderly, and that's least replicable field. And our selection of studies and organization and personality psychologies tend to be more replicable. But again, as I said, this is just one represented by 1 journal. So I don't want to claim that this pattern will hold throughout, because there are definitely many for like developmental psychology. This is just 1 journal, child development. There are many other top journals in that field that's not included here. So this is just a snapshot that we currently see. But what we did test was, because these papers come from different journals, we did want to go 1 step further to look at the different disciplines publishing in the same journal. So we look at their papers all publishing in psychological science, the same journal, but in different field. This is to rule out that the differences were due to differences in journals, like formatting requirement, rather than the actual disciplinary differences. And we found that the pattern largely mirrors the previous one. The only difference was between, I think, clinical and cognitive psychology. The order was flipped, but like developmental was still, and social were still less replicable than organizational psychology and personality psychology. And finally, we have this training sample. Then those papers were actually replicated, and the success rate also mirrors the pattern, even if we just have papers for enough sample for 3 disciplines. But among these 3 disciplines, we found that social psychology is less replicable, cognitive psychology more so, and then personality psychology is the most replicable field. And like, why is that? And we did make 1 attempt trying to answer that, and we further separated those papers by research method, experiment versus non-experimental research. And for each field, you can see like the boxes are, the size of the boxes is the percentage of studies, other experiments versus non-experiment in each field. And then the horizontal line is the average replicability. So in general, experiments were less replicable than non-experiment, than like observational research. And that is a pattern that the effect size is very large. So we did see that experiments are less replicable than non-experiments, potentially because experiments have smaller sample sizes. The average sample size in the training sample for experiment is just half of non-experiments. So yeah,
Could it also be a function of whether people have a directional hypothesis? I would assume with experimental research typically have a clear assumption.
Yeah, that could be possible too.
Experimental research may be
Yeah.
a more explorative way.
Yeah.
And therefore, I think there's also less risk.
Yeah, definitely.
Of not proving your
Yeah.
your hypothesis.
But that's not about proving, it's about replicating very often.
Sure, but you may be more inclined to have a study, right, that actually fits the other studies, given that you have that directional hypothesis. Whereas with non-experimental research, you basically are less inclined to cheat in any way.
Yeah.
But isn't this a direct outcome of the training data? I would assume that the 388 probably are almost exclusively experiment.
Not exclusively
okay.
experiment. Yeah, so there are I think 20% of them that are not experiments. Yeah, so it's not balanced, but it's not exclusive. Yeah, and it's not like all experiments are, if you're an experimental paper, then you automatically low in replicability score. It's not. There is like variability as well. So it's not just that. But this is a pattern that we saw, and it might partially explain the subfield differences. I'm not sure. This is just the 6 data points, and each data point is just represented by one journal. But I still want to put it out here, just as a like very preliminary hypothesis that because cognitive psychology, social psychology is heavily experimental, and they use smaller sample sizes, and therefore they are less replicable than personality psychology or organizational psychology. Yeah, what do you guys think? Does this align with your intuition? Yeah.
I was actually thinking about, because I have my master's in developmental
Yeah.
psychology, and we have to test kids.
Yeah.
They come in one by one, and it's so hard to get these samples, right?
Yeah.
And so that might be something similar for clinical psychology.
Yeah.
Right? If you're looking at, a specific schizophrenic population, right?
Mhm.
Both of those samples, young kids and people with
Yeah.
psychological issues, they're hard to get to, so you might have smaller samples.
Yeah.
I was wondering, at least for those two, I mean, I also have some experience with social psych. I know
Yeah.
there might be other issues there. But for example, IO psych and personality, right? If you're talking about the general adult population,
Yeah.
sample access is
Yeah.
an issue. So.
Yeah, definitely. And it could actually explain, because developmental is not highly experimental, but it's low in the replicability ranking. So it could be that the quality of the sample and how hard it is to access the population makes a difference too. Yeah.
2 quick ones. I think on the training data, I think it would be nice to have a quick sanity check that the behavioral versus experimental data really had similar replication scores, because I don't know, intuitively I would have guessed that it's that there's a higher non-replicability in any paper that has experiment as a word in the abstract.
Yeah.
So that would be a very simple feature that is explaining the majority, and that maps on what you're finding here as well.
Yeah.
Right? So I think it would be good to have a sanity check.
Yeah.
That it's not the case that just in the training data, there's always the best prediction if there's just a single word experiment present in the data.
Yeah.
And second, following up on this, I think it would be also nice to white box more what kind of dimensions are picked by the word-to-vec model. So I think what you did with line before, you could do it also. There's something that's called line maps. Probably you know it. So you could use the line maps to illustrate what kind of features are associated with those dimensions to understand. Well, maybe there's a class of words in one dimension that is about, I don't know, experiment, but also, I don't know, maybe they talk about effect sizes already in the abstract. So I think more white boxing and maybe even also visually using a line map, I think would be super.
That's a good idea. We didn't go a step further to did line map. We were aware of that, but we didn't do that. Yeah, that's a good idea. But I would say like one robustness check we did. So going back to this question about the training data not having clinical or developmental psychology. So we in our prediction model, we only use text, but not reviewer metric. We remove all the numbers, but we independently extracted the number, like the reviewer metrics for developmental psychology and clinical psychology. So, and we found that those reviewer metrics correlate quite strongly with our prediction, and it's not repetitive because the prediction model doesn't have information about those review metrics. So that's actually, I think, a very robust check of the predictions using different information. We arrive in the same conclusion about how replicable a study is. But again, I think it doesn't address your question, the concern about because experimental psychology has lower sample size. It's a fact that experiments replicate less easily. Even in the training sample, they replicate, the success rate is half than the non-experimental research, and that they have smaller sample sizes. So in both cases, using reviewer metrics versus using text method, you can easily identify which studies are experiments. So yeah, I guess it doesn't rule out that possibility that when the model sees a small sample, or when the model sees the word experiment, like it gives it a lower score automatically. Yeah.
Quick follow-up. Did you ever plot against each other replication score, the one you get versus sample size of the study?
Yeah, we did. There's a I think the correlation was 0.4 or something. Yeah. That's actually quite interesting because our model does not have information about sample size. Yeah. But like it corresponds to sample size. Yeah. As well as p-value, as well as power. Yeah. That's all correlated. Okay, so back to this mountain of replicability scores. And in the final couple of slides, I want to talk about what we can do with it. I thought of two applications of these scores that we came up with. And the first is to, as I said, we could use that to decide which replication study we want to do first. And the second is to use those scores to explore the relationship between replicability and other metrics of a paper, like the citation number, the media score, things like that. So going back to this purpose, as I said, now we can fill in this part of the equation, how uncertain we currently are about studies, and use that to decide what studies to prioritize to replicate. And this is just a scenario that I propose where you would have all the papers lined up for each subdiscipline. And then within each discipline, you could sort the papers by their replicability score. And you would have studies that are very unlikely to replicate to those studies that we are very sure would replicate, decided by the scores. And you would have scores in the middle that we are currently we're most unsure about. And according to that decision framework, those in the middles would be the ones that we will want to replicate most. And of course, it's not just a function of uncertainty of the outcome. You can also look at the value of knowing the outcome. And in this hypothetical examples, this paper has like a middle range replicability score, but high citation number. So maybe we want to follow up on that one, like doing a prediction market first to see how people feel about it. And if prediction market result also comes down to 50-50, then we can consider replicating it. And of course, there's this huge factor in deciding whether to replicate a paper is how feasible it is to replicate a paper. Then we can fill in additional metrics like, is it easy to be executed online? Is it a longitudinal study? Does it include hard to reach populations? So this whole system can help us decide which resources to put in terms of replicating. This is actually happening because, as I said, like this organization called CREP, they do publish each year a list of studies, and they suggest undergrads to replicate. Currently, it's largely based just on the last column, how easy it is to replicate, but now we can supplement all these other metrics to help students, to help us as a field to more efficiently move when it comes to replicating studies. So that's the first thing we can do with these scores. And the second thing is that we can explore the relationship between replicability and other meta science metrics. And this is actually the first time we can actually do it with a larger sample size. Before, if you want to examine the relationship between replication and outcome and these metrics, you're restricted to a very small training sample data. And there's actually a few papers published on that using that very small sample, but now we can replicate that or like extrapolate using a larger sample. So here are the results. It's a quick summary of the results. And I want to say that each result is validated by both the training sample, the actual replication sample, as well as our predicted score. So in both cases, the results were align with one another. And overall, we found that citation number is not related to replicability. And institutional prestige of the author is not related to replicability. But we did find that replicable papers tend to receive less media attention than non-replicable papers, and potentially because non-replicable papers tend to be more counterintuitive, that catches media attention, and at the same time less replicable. But the effect is not huge. It's just like a correlation of 0.21. It's not huge, so only slightly less media attention compared with non-replicable papers. And finally, we found that replicable papers tend to have first authors that are more experienced. The first authors of replicable papers have published more, like accumulated more, higher number of publications and have been cited more. Again, like small correlations, but it's not negligible. And we didn't find that for senior authors, so that exists only for first authors. So so these are the metrics that we explored. And if you, because we now have this large sample of replicability, if you have interest in other metrics, we're able to explore that for the first time now. Yeah, that's it for now. And thank you for your attention and all those great questions. Yeah, and happy to take more questions. Thank you. That's your thing here. Okay. Yeah.
I was wondering, why did you decide to go with Vect instead of something like a language model like GPT and extract the embeddings? Because my intuition would be if you would use over 12,000 dimensions of embeddings, which are already like out there, you don't have to do anything. Wouldn't that be more accurate and even improve?
We did try. It didn't improve for some reason. Yeah, we did try. So we just went with like the most simplistic and the most the old school way. Yeah, we did try with more dimensions and different methods, and it didn't improve the model. Yeah. Mm-hmm.
Two questions. First of all, so fascinating work. Could you tell us a little bit more about the replicability score? Can you maybe give us some examples of words or sentences that are higher or lower on this y-axis, just to get a better feel for what it actually does?
Yeah, the thing is that we didn't find examples, like common examples of if you have this word, then it would definitely be higher. We tried not just using limes, but we also like look at what do they call it? There's a list of probability words that people use, so to indicate how certain you are about things. And we didn't find that to be indicative of like what the model would predict. So we did try a couple of hypotheses. That's the thing about this black box model. Yeah, you can only come up with hypotheses and then test it. We did a few things with it and didn't see any pattern that we predicted. Yeah.
Okay. Just a follow-up on the ground truth that has been mentioned before, and too, what you want to make sure is that this ground truth is actually ground truth and not biased, right?
Yeah.
Maybe you can tell me a little bit more about those 388 papers or studies that are included there.
Yeah.
Because I would assume, so they're not all picked randomly, are they?
No.
That some of them are, right? They pick randomly some studies, and that's of course great.
Right.
Others are probably not picked randomly. But to what extent do you actually predict replicability and not to some extent, I don't know, what people think is replicable or not?
Yeah, that's a good question. That is a limitation because replicability, as I said, is not black and white, and it's hard to decide whether a study would ultimately be replicable. There's no I would say that even if our model is perfect, the ground truth is not perfect anyway. And most of the study was replicated only once. And there were a few papers that were replicated multiple times, and they came with the conclusions were the same. But it's true that most of the papers were only replicated once. And there's some uncertainty around the ground truth. And
But I
yeah.
just can't change that.
Yeah, that you can't change, like personality scores. There's always this retest reliability. That's the ceiling of accuracy you will get. Yeah.
I guess what you could do, I don't know what the share is of randomly chosen studies versus non-randomly chosen studies, and see whether your model predicts as well those that are randomly chosen, or how it performs in that case.
Yeah, there's only, I think there are 100, 150 that were randomly chosen. Yeah. Yeah, so we can look at that. Yeah.
I just had a follow up on the white boxing, so understanding what's going on under the hood. I think two strategies would be one to take the replicability score as an outcome and specify less so where you predict with the tokens and also with the n-grams.
Yeah.
The replicability scores, at least that you get a sense of what features are getting picked. And also following up on the line maps, I think the line maps would also help, and also to look at the line maps by discipline. Because for example, I don't know, I think for a social psych, I would intuitively guess that things like priming are probably associated with lower scores.
Yeah.
So these line maps would then also help to understand, okay, what are the dimensions? Certain keywords.
Yeah,
So
I'm actually, I will do that, I think. Yeah, that's a very good suggestion.
And there's also something else, it's called supervised topic models. So there you could also take your replicability score and specify a supervised model where you want to predict the replicability scores based on features that are grouped into topics. So I think there are options, I think, to better white box.
Yeah. That's a good idea. Yeah, I will do that. Cool. Another question? Yeah.
I mean, I would be also interested in, do you expect now that the next big thing we basically see is replicability hacking, so to say? So I just put in my text, that it says like, your study will not replicate it. Then I just change to throw it in again, and then it says, nice. And I'm like, let's submit, no one will ever question me, great paper, 10 out of 10.
Yeah, because currently, as I said, it's very much of a black box, so it's not possible to do. Maybe like after I did what Christian suggested, you were the first one to know what words to put into your papers to prompt.
That's right. I mean, I just do like brute force things. So I just throw it in, it gives me a low score. Okay, I know low score before I submit. I rewrite. So rewrite, then I try again. So, and then I just ask ChatGPT, rewrite that 20 times, and then I automate it, and I send it 20 different versions to your algorithm. Then it helps me.
Yeah, it could be.
The highest replicability, and then I just submit it.
Then you get less media attention.
Also,
it could be.
That's always possible.
Yeah, but like, yeah.
It just improved to fraud. I mean, the results are still the same. I just changed the wording.
Yeah, it's a good point.
In my opinion, that's not misconduct. So I think it's a great method for papers that are already available. But I think once you publish that, someone might come up with an idea like the one I have.
Yeah. Rightly so, yeah.
I was wondering about this as well, because I know we don't know much about what's in this black box, it seems, but phrases like, this brings up questions or raises doubts or things like this. Would that be something that could be flagged just intuitively because you know this data much better? I'm just thinking this because a colleague of mine at Zurich, she just published a study, right? We know that kind of public trust in science is on a decline. But they published in Nature Climate Change, basically the climate scientists who expressed some doubt actually increased trust in the public because they were expressing some doubt. So I was almost wondering, like down the line, if kind of building on this as well. How we as authors are supposed to describe our research and how that affects a number of other things. And
you mean if we can use this system to flag things that are not replicable, or?
Well, I mean, me as a scientist, I'm very interested if my work is replicable. But I think people who are less interested in the mechanics of the machine learning models and replicability, like they're just thinking, what does this mean for me and my science? Like, what do they do with that? And that could be some concerns or some thoughts that they have.
Yeah, my collaborator would say that you can use this like as a self-check tool. But I actually think that's you can actually. My hypothesis is that usually authors knows how confident they are about their research. So actually, I do want to do a studies, but I'm not sure how feasible that is. There might be a lot of difficulties. I want to collect authors' confidence in their own research and then compare that against our model, because our hypothesis is that the way people describe their findings reflects their confidence and therefore replicability. We can maybe collect a small sample and then validate it against that. If that is true, this model is still valuable because we can't collect authors' confidence for like 14,000 papers, right? And they might not be able to, they might not want to tell you that, but then that's like more validation for this model, then it's what it's doing, like it's reflecting authors' confidence.
I mean, related to that point, what about papers with multiple co-authors, right? I mean, how many times have you all submitted things to a co-author and like change all of the words in your abstract, right? And I'm just wondering, especially about like Amy Cuddy's paper, right? She was momentous in this replicability crisis, and clearly it came out that one author was less confident than the other author. So
that's the difficulty of doing that kind of studies. Like they might not want to tell you, and they might have concerns. So like it will be difficult, this kind of data. But maybe you can collect for multiple authors and average them. That could be a possibility.
One more suggestion. Regarding the Christian side of mine, because I would also be highly interested in like the black box and then what is exactly predicting the score. And I like to use check values, which are like very similar to line scores. And there's also the idea like what is in comparison to the average prediction, like why is this either specific sample or specific manuscript in this case highly like why does it have a high predictability score? Or like just compare the extremes and see like for these individual cases, what's the main difference, and then you can kind of visualize if there's, for example, embedding number 702, or in your case you only have like number 100, then you can kind of look into embedding number 100 and see like word clouds or whatever.
That could be good to do as well. Thanks for that. Any other suggestion?
Maybe me also following up on Jan's question with the word to Vect. I mean, why did you then basically decide to run a random forest? I mean, especially with the amount of data, and it was that the main reason. I mean, you could have also used like I don't know, deep neural networks or like that. But I think that you don't have enough data for that.
I don't have a good answer for that because the model was actually run by my collaborators, Young. He's a computer scientist. I'm actually not sure. I can ask him. I'm not sure why this is his choices. Sorry about that.
I was just curious if there was a reason behind it.
I don't.
I have two quick questions. So one, it's more about like I mean, people are writing papers, right? I mean, people are using certain language, but they're also writing the papers. And of course, I mean, you don't want to label individuals. But what made me curious was the fact that you looked at these individual factors more, let's say, isolated, right? Male, female, a prestigious institution. But I think it's a joint distribution within a person, right? So is it a male author? Is it a young PhD student? Is this PhD student coming from a top tier institution where there's a lot of pressure to publish? Right? So I think exploring maybe just for your internal
Yeah.
curiosity.
Yeah.
Looking at it individually, yes, you can check mark the. I mean, and it's also good. You probably because you probably don't want to say, well, we can label people, right? Male, young author, top institution, competitive pressure, higher likelihood to not replicate.
Yeah.
Right? But I think it would be interesting to explore a little bit more like joint distributions as opposed to looking at it.
Yeah, that's a good idea. And yeah, maybe so it's sort of like going back to this, but like jointly rather than individually, right?
Right. Exactly.
Yeah.
And the other thing is a bit more like a high level umbrella. What do you think this is doing to science in general? So I mean, for authors, but also for journals and editors, where do you want to bring this toward? Is it for like the internal check what Philip was suggesting, or for editors, and he had a great idea that could help to select those papers going forward to do more like manual replications. So I'm curious, where do you see this going, and what do you think this is doing to science individually, but also as a system of science?
Yeah, as a system of science, I think this can be used to, like as I mentioned at the beginning, the first purpose of replication. So I do know that it has been proposed that we should replicate a random sample of studies every now and then in a certain discipline. And maybe this method could be used as a preliminary filtering even for that purpose as well. So like very practically, I think right now I'm just I'm working with this organization to help them choose studies what to replicate for undergraduate psychology. I think that's our best bet. Like who would do replications? Undergraduate psychology students or master students doing that for their replications. I think realistically they are most likely to do replication. It's good for their them as an exercise and contribute to this movement. So like I think I don't think it's I don't think at the moment we would help change the journal anyway or journal decisions anyway, but more so it's more likely that we can apply them to past studies and help people do replications more efficiently. Yeah. Yeah, and yeah, I'm very cautious because it's a black box. I wouldn't want to see journals or funding agency adopt it and base their decisions on that. I don't think that's a responsible behavior. But it's actually funny how like people would question this black box, but if you think about the prediction market, it's also a black box. It's a black box in people's mind. You don't know why people decide why this study is not replicable, but people trust that decision more. Yeah. Yeah, algorithm versus.
You can ask those individuals, right?
Yeah.
They may give you also biased answers.
Yeah.
Yeah.
How do you see the potential for this to be applied to different disciplines? I know that we talked about this. Some disciplines is the replication crisis thing is more aware, and others not so much a topic. Do you see this like being applied to, for example, consumer behavior or something?
Yeah, this method in principle can be replicated in any discipline, but it's important to have a large training sample which is not present in most of the fields. We did try to apply this algorithm to papers in economics. It didn't drop to baseline, but it wasn't like very good. So like we wouldn't use it in practice. But if like another field, but as other fields start to accumulate training data, then it's possible to apply it to another field. Yeah.
I'm wondering how you approach this as an author and potentially publishing this, right? In PNAS or somewhere. Because right, these papers, they're are done by people.
Yeah.
Right. And some of these people might be not tenured or you know, at the associate level waiting for professor.
Yeah.
And so they might have one paper on here that has a low score and another paper that was amazing but wasn't in the data set.
Yeah.
Like how do you as an author weigh these like pros and cons and the sensitivity of
so that's why actually so far I actually want to get some ideas from all of you. So currently we are open code, but we're not opening the final score, precisely with that concern that we don't want anyone to be judged in the court of Twitter that, oh, this is, and I emphasize, even if I emphasize that this is not definitive, like we should use other methods to cross-check it. And I am still worried about like people having a low score here and then their reputation is affected in some way. But I actually haven't thought of a good solution for that. Yeah. Do you have any ideas? What's the best way to release those scores? Yeah.
Well, not on an individual basis. Not sure whether there's another solution.
Yeah.
Break it down, right? To changes over time, sub-disciplines, which is shown anyway.
Yeah.
More prestigious, less, but on an individual basis, it'll be difficult.
Yeah.
I mean, it also means different things, right? The replicability score could be low for many different reasons. It could be because people are not doing proper science. It could be because it's just a very unlikely thing to be true. It could be because it's a false negative. It could be a false positive. Sorry, it could be because for many other reasons. You know, that's I think what will be problematic if we use it to flag people, because you know, if you do high risk research, for example, or in a novel area, it's more likely, I would guess, to not replicate. It's not that likely that you replicate. So maybe you would need a model that would basically detect fraud or something like this, or basically p-hacking and those kind of things, you know, because then I think it's a different story. Then it's more warranted to say, I'm going to label that paper because it's going to do damage to the scientific body of literature. And it's going to do damage to the society if it's going to be picked up by policymakers and media. Whereas if it's just risky research, or if it's, you know, any of the other reasons that are not basically the fault of the author, then I think it's not warranted to blame the person. That's something a challenge here.
Isn't fraud really hard to detect?
Super hard. But I think, I mean, for now, you're suggesting it because I like the combination of having this score plus the attention, the automatic thing. Because that basically tells you, based on our rough estimate or screening device plus the attention this research is getting, it's warranted to take a second look.
That's the whole point.
It could also be something really groundbreaking, you know. I don't know, drinking this water here is dangerous for you, you know. If you find that in your research, then it's probably warranted to do a check, you know, because it affects many people and has raised attention.
There is a project that is, I think, from a couple of months ago. If you now publish in Science and Nature, they're going to replicate it, all of it. So if you want to publish in Science and Nature, be ready to be replicated. They are actually doing that, and they are giving like a it's not in that case it's not black and white. I think they replicate all of the experiments in your papers and then decide they give you a star, like 1 to 5 star, how robust is your research.
With your own data?
No, that has nothing to do with this. They collect new data.
Behavioral studies?
So psychology, behavioral studies, they would actually replicate. But like that's an easy decision because there are only like 5 papers published in Science and Nature a year, maybe 10 in psychology. but so we can easily replicate them, and those are high stakes, highly cited, lots of public attention. But what about these other studies that were published in psychological science, JPSP? Yeah, that also gets a lot of attention and builds the foundation of the field. Yeah, which one do we replicate? So yeah, that's why we want to propose this method to help refine the procedure. Yeah. Oh.
Thank you so much.
Yeah, thank you. Thanks, everyone. I'm going to bring that back. Yeah.
Very cool stuff.